Yeah, this is another example of the conditional probability. Here the question says a school employs 75 teachers. The following table summarizes their length of services at the school, classified by gender. So we have a school employs 75 teachers. The following table summarizes their length of services at the school, classified by gender. Okay, we have the table here. We have on the first column the female male, where we have 10 years to 30 years. Those who have spent 10 to 30 years or 10 to 20 years in service. Then those who have spent 20 to 30 years in service, and those who have spent above 30 years in service. We have their number. The female of them is 12, the male is 8. For those who have spent 20 years and between 20 and 30 is this. So the question now is, we are being asked to find the probability that at a random that a random selected teacher find the probability that a random selected teacher is female. So how do we do this? How do we find the probability of, if you are picking a person from this entire number of teachers, what is the probability that such a person will be female? So all what we need to do is to extend the row and the column by just one. So we have this, and you also extend the column by one to have this. So what do? You now add each of the column. 12 plus 8, 20. This 20 here represents people between 10 to 20 years is just 20, they are 20. Then between 20 and 15, this is 35. There are 35 people, so you have this place to be total. So here we have 13 and 7. Those people in that category, they are just 20. And here also you put total here. So the both horizontal and the vertical total must be the same. So here we have those who are female among them. Females among them, 12 plus 20, that will give us 32. Then 32 plus 13, that will give us 45. So we should have this column to be 45. So also is the second row. We have 8 plus 15, that should be 23. 23 plus 7, that should give us 30, I think. So when we have 45 plus 30, 45 plus 30, that is 75. So also is 20 plus 35 plus 20, it is also equal to 75. So that simply means the possible outcome is 35, that 75, that 75 persons are in attendance there. So the probability of letting a female, you go to the column of female. How many female do you have? We have 45 in number. So probability of picking a female becomes 45 over 75. Of course, you agree with me here that 5 can divide this. 5 goes in 45. That should be 9. 5 goes in 75. I think that should be 5 goes in 7. That is 1. And in 15, in 25, that is this. And 3 goes in 9 is 3. 3 goes in 15, that is 5. So the probability of selecting a female person in this set of teachers is given to be 3 over 5. The same thing is what we do on question 2. Question 2 says, what is the probability that the person choosing is female, given, this is the condition there, given that the teacher has more than 30 years experience. So the teacher has spent more than 30 years, above 30 years, and like I told us, we have the formula. The formula still remains that the formula remains that probability of the person we are choosing is a female, given that the person also has an experience of more than 30 years experience. So this will give us the intersection of female and 30 years. Intersection of female and 30 years here becomes female and 30 years. They intersect at 13. Their value is 13 over then more than 30 years. How many are they? More than 30 years. More than 30 years are is just 20. So we have the probability to be this. I come again. The question says we should find the probability that the person choosing will be female, given that the teacher has more than 30 years. That means we are selecting from 30 years of age in service, more than 30 years in service. So we have females there in that category. The intersection is 13, while the total number of people above 30 years in service is 20. That gives us this. For the second question there, or the third question, the question there says that is the person we are choosing now is female, given that the teacher is 12 years. The person is female, given that the female, given that the teacher is 12. Okay, let's put it here. Okay, let's say between 10 to 20 years, between 20 to 20 years. I spent between 10 to 20 years. So the intersection of female now and 10 to 20 years is just 12. So we have 12, 10 to 20 years. We have 12 over, it is still going to be over the total for this, and the total for this is 20. So you can see, as you can see, this is over 20, which will give us that should be 3 over 5. Now a question can still say, okay, let's formulate a question here as fast as possible. So this question saying that what is the probability of maybe the person is going to be between 20 and 30 years, given that it's a male, given that the person is male. So that means we are looking at the intersection of 20 and 30 with male, 20 and 30 with male, 20 and 30 with male, that is 15. So we come here and put 15 over, then what is the total male, the total number of male that we have there, total number of male we have here is 30. Total number of male is 30. So that means we have this to be over 30, which will give us 1 over 2. I come again. Probability of picking a person between who has worked 20 to 30 years and given that such a person is male. We look for the intersection of 20 and 30, 20 and 30, 20 to 30 and male, which is this 20 to 30 male. The intersection is 15 over the total number of male. And lastly, the question here says 2 teachers are selected at random. Find the probability that they are of the same gender. Of the same gender simply means probability that it is male male or female female, which is the same as probability of male male plus probability of female female. And what is male male? Probability of picking a male. The male staff, the total number of male staff here is 30. So we should have this one as 30 over total number of people there, 75. 30 over 75. Now times, because we are talking about male and male, times, if the question says with replacement, then the numerator reduces. But if the question says, and the denominator also reduces. But if the question says without, okay, with replacement, the numerator and the denominator remain the same. But if it is without replacement, then it reduces. So we are solving this one now as with replacement. So that will give us 30 over 75 plus female. How many female do we have? We have 45 female out of 75 persons. So 45 over 75 times 45 over 75, and from here we simplify. 15 here, that is 2. 15 in 75, that should be 5, times 2 over 5 also in bracket plus 15 in 45, that is 3 over 5 times 3 over 5, and from here we can have, this is 4 over 25 plus 9 over 25, which will give us 13 over 25. Don't forget, what we have solved here is talking about probability that they are of the same genders, which could be male male or female female, and this is still talking about with replacement. That is why the denominator remains the same for the two and the numerator remains the same for the two. I believe you have gotten something on this. Thank you.